Welcome to my channel Learning Electronic Circuits. Today I am going to explain the various methods of checking the status of a capacitor. We'll go through the 4 different methods to test a capacitor and also the various steps involved in it. While working with electronic circuits and troubleshooting, at times we need to check the status of capacitors. The capacitors may be good or it may become short-circuited, open-circuited, burnt or exploded. These damaged capacitors in a circuit will cause the circuit to malfunction or cease its function. For testing a capacitor, it must be taken out of the circuit and discharged before it is being tested. This is because of the high static voltages or charges collected between the plates of the capacitor. There are mainly 2 ways of discharging a capacitor, and they are as follows. 1. Screwdriver method. If a capacitor is in a circuit, remove the capacitor from the circuit. Take a screwdriver that has an insulating handle. Hold the capacitor on one hand and touch the terminals of the capacitor using the screwdriver on the other hand. The capacitor discharges through the screwdriver, causing some sparks and crackling sound. Ensure that the capacitor is fully discharged. 2. Discharge resistor method. A high value resistor of high power rating 1 kΩ 5 watts is placed across the terminals of the capacitor to be discharged. This discharges the capacitor slowly as it bleeds the charge present in it. In power supplies, it is called as the bleeder resistor. The 4 different methods used to test the function of a capacitor are as follows. Method 1. Step 1. This method tests a capacitor for its charging sequence to check whether it is charging normally or not. An ordinary digital multimeter is selected in the resistance mode. For a normal capacitor, the reading on the multimeter shows a lower resistance initially and gradually increases in resistance, then crosses the open line or over limit. This indicates that the capacitor is charging from the voltage drawn from the multimeter, and the resistance increases to infinity when it is fully charged. The displayed values are noted down. The resistance scale of the multimeter is selected in the lower resistance scale, such as the 200 ohm, 2 kilo ohm, etc. for checking the capacitors with values more than 1 microfarad, such as the polarized capacitors like electrolytic capacitors, standalone capacitors, etc. A higher resistance scale is selected for testing the capacitors of lower values below 1 microfarad, such as the non-polarized capacitors like ceramic capacitors, metal film capacitors, mica capacitors, etc. This test is done with the following steps as given below. 1. The capacitor must be removed from the circuit and fully discharged. 2. Select the digital multimeter setting in the ohms or resistance scale. 3. Connect the probes of the multimeter to the capacitor terminals. The negative probe is connected to the negative lead of the capacitor and the positive probe is connected to the positive lead of the capacitor. 4. The digital multimeter will show some momentary reading starting with a smaller value and briefly increasing in value. Then suddenly the reading stops and shows OL, open line or infinity. Note down the reading. 5. Disconnect the capacitor from the multimeter and repeat the steps from 1 to 3. If the reading remains the same, then it is a good capacitor. 6. If there is no reading on the multimeter, then the capacitor is open circuited. If there is a low reading on the multimeter, then the capacitor is short circuited. If there is no change in resistance on further tests, then the capacitor is dead. Step 2. The multimeter scale is selected in the continuity mode and the capacitor is tested to check whether there is any open circuit or short circuit. In an open circuit condition, the multimeter does not show any reading, while in the short circuit condition, the multimeter shows a low resistance value and the buzzer will sound. Method 2. In this method, the capacitor is tested using a digital multimeter or an LC ammeter selected in the capacitance mode. This is a mode that directly measures the capacitance values. It measures even very small capacitance in the picofarad range. The value written on the capacitor is compared with the value displayed on the capacitance meter. If the value deviates more than 20% from the actual value written on the capacitor, then the capacitor is a faulty one. This test is done with the following steps as given below. 1. The capacitor must be disconnected from the circuit. 2. The capacitor is fully discharged of any residual charge. 3. The multimeter is now switched to the capacitance mode. 4. Connect the probes of the multimeter to the capacitor terminals. The negative probe of the multimeter is connected to the negative lead of the capacitor, and the positive probe of the multimeter is connected to the positive lead of the capacitor. 6. The capacitance meter gives the capacitance measurement onto the display. The units used to measure the capacitance value are picofarad, nanofarad, microfarad, millifarad, etc. 6. The value displayed on the screen is compared to the marking written on the capacitor and assessed for any variation. Method 3. In this method, the capacitor is tested for its discharge sequence using a multimeter. Here the capacitor is charged by connecting the terminals of the capacitor to a battery for a brief period of time. The battery is then disconnected from the capacitor. This charged capacitor is connected to the testing probes of a multimeter in the correct polarity to study the discharge sequence of the capacitor. Alternatively, an LED bulb in series with a 1 kΩ resistor is connected to the capacitor terminals to get a visual display of the discharge, or a buzzer to get an audible sound. Method 4. In this method, a visual examination of the capacitor is done to check its physical condition. Any external damage is easily identified by visual examination of the capacitor. Physical damage of a capacitor may lead to short circuiting. A burned capacitor may be identified by the burn mark seen on the body of the capacitor. Capacitors may also be damaged by dielectric breakdown, causing the plates to short circuit. Polarized capacitors may be destroyed by reverse polarity, high voltage, or spikes. These capacitors may leak its electrolyte outside. Polarized capacitors may also bulge or explode when it is operated outside its working parameters.